The topic for discussion is setting up primary electrochemical cell system and the production of electric current. Any electrochemical cell system must consist of two metals as electrode. These metals must have different standard electrode potential. That is, the two metals must be of different reactivities. On the tutorial board are the various setup for electrochemical cell system that we can have. There are 5 systems above. The zinc ion zinc electrode coupled with copper ion copper electrode. The second one, the magnesium ion coupled with magnesium electrode, the magnesium ion magnesium electrode coupled with zinc ion zinc electrode, and so on and so forth. Each electrochemical cell system consists of 2 separate half cells, and these half cells are separated by a double stroke, which represent the salt bridge. On the left side of the double stroke is the anode, and on the right side of the double stroke is the cathode. For this our discussion, we are looking at the first system, consisting of zinc ion zinc electrode coupled with copper ion copper electrode. How do we set up this electrochemical system? Zinc metal rod as electrode is deep into solution of its salt, that is deep into solution of zinc tetrahydrosulfate salt as electrolyte in one half cell. In the other half cell, copper metal rod as electrode is deep into solution of its salt, that is copper 2 tetrahydrosulfate salt as electrolyte in another half cell. Having set up the 2 half cell, that is zinc metal deep into solution of zinc tetrahydrosulfate in one half cell, and copper metal deep into solution of copper 2 tetrahydrosulfate in another half cell. The solutions in the 2 half cells are now connected together by a salt bridge, while the 2 electrodes are connected to a bulb or galvanometer by means of a wire. When the two half cells are coupled together, an electrochemical process begins, and the cell begins to generate current. The zinc metal rod, which is the more reactive of the 2 metals, that is, zinc is the most reactive between zinc and copper ion. The zinc metal serves as the anode, and it loses electron and goes into solution as zinc ion. The additional zinc ion results in excess zinc ion in zinc half cell. It is important to note that some of the electrons lost by the zinc rod are deposited on the zinc rod, and this makes the zinc the negative anode. The remaining electrons that are lost are pushed through the wire to the cathode. Thus, the flow of electron and current in any electrochemical system is from the anode to the cathode. The copper rod, which is the less reactive of the 2 metals, serves as the cathode, and it gains electron from the anode. The copper cathode loses the electron gained from the anode to the copper ion in solutions, and the copper ions are deposited on the copper cathode as copper atom. The removal of copper ion from solution results in excess tetrahydrosulfate ion in the copper half cell. I said earlier that the additional zinc ion that dissolves away from the zinc anode and go into solution result in excess zinc in the zinc half cell, and in the copper half cell the copper ion gains electron from the copper cathode and is deposited on the copper cathode as the copper atom. This removal of the copper ion from the solution of the copper ion in the copper half cell results in excess tetraoxosulfate solution. This imbalance of ion in solution will affect the flow of electron and subsequently stop the generation of current. This imbalance of ions can be corrected using the salt bridge or porous pot. What does the salt bridge does, or the porous pot? They allow the exchange of ions to take place between the solutions in the two half cells and thus ensure electrical neutrality. We want to write the half cell equation at the anode and half cell equation at the cathode. At the zinc anode, I said that the zinc, being the most reactive, loses electron and go into solution as zinc ion. So the zinc atom here losing 2 electrons and giving us zinc ion on the other side of the equation. Now for the copper cathode, the copper ion in solution gaining 2 electrons and giving us copper atom on the other side of the arrow. How do we write cell notation for electrochemical cell? Cell notation is the combination of the half reaction at the anode and the half reaction at the cathode without showing the number of electrons. And we now use a double stroke to separate the two half cells. On the tutorial board, we have the zinc ion stroke, we have the zinc atom stroke the zinc ion coupled together with copper atom stroke copper ion. So that is the cell notation for the cell. What is a salt bridge? The salt bridge consists of high concentration of potassium triazonitrate 5 salt solution. It allows potassium ion to move into the copper half cell to replace the copper ion that is lost in solution, while the triazonitrate 5 ion moves into the zinc half cell to balance the excess zinc ion in the zinc half cell. Functions of the salt bridge. The salt bridge allows exchange of ions between the solutions in the two half cells. The salt bridge ensures electrical neutrality in each half cell. The salt bridge connects the two half cells together. Thank you.